Welcome to this video from Creative Learning Resources on how to get a 7 in IB Chemistry series. This video is mainly for IB Chemistry students, but IGCSE Chemistry and A-level students can also find it very helpful. This is about topic 9 and the second lesson on 9.1, Oxidation and Reduction. We will be learning today the rules for determining oxidation states. So let's get started. In this video, we are going to cover subtopic 9.1 Oxidation and Reduction of topic 9 Redox processes. A very important and crucial part of redox reactions is how to determine the oxidation state of an element. So we are going to learn some rules how we can determine the oxidation state of different elements. So the first thing first, for the ionic compounds, the oxidation state of each element is equal to the charge carried by each ion. For example, in case of sodium chloride, the oxidation state of sodium is +1 and the oxidation state of chlorine is -1. In case we are dealing with a covalent compound, then we will assume the covalent compound as an ionic compound, and the element having higher value of electronegativity is going to form the negative ion. For instance, in the case of ammonia, which is a covalent molecule, the oxidation state of nitrogen is -3 while the hydrogen is +1. So the next rule to remember is the algebraic sum of all the oxidation states in a compound is always considered to be 0. Means a compound has overall no charge, so we'll consider the overall oxidation state of a compound is equal to 0. For instance, while determining the oxidation state of an element in a compound which is unknown, we will consider the oxidation state of the whole compound as a whole is equal to 0. Let's say the oxidation state of the unknown compound is X. As we know that the oxidation state of hydrogen is +1 and there are 3 atoms of hydrogen element, so we'll multiply the oxidation state of hydrogen with 3. Now we know that there's only 1 atom of phosphorus in this compound with an unknown oxidation state of X. In addition to that, there are 4 atoms of oxygen which is having an oxidation state of -2, and the overall oxidation state of this compound should be equal to 0. Now solving this equation, we can find out that the oxidation state of phosphorus is equal to 5. So this is a very easy but effective way of finding out the oxidation states of any element present in a compound whose oxidation state is difficult to predict about. Now the next rule which we're going to learn about is for an ion or radical. So the algebraic sum of all the oxidation states in an ion is always equal to the charge on that ion. For instance, in MnO4, having a charge of -1 could be mathematically written as this equation, in which we can see that the charge of MnO4 is -1. The next rule which we are going to look into is about the elements which are not combined with any other elements. In such case, the oxidation state will be equal to 0. For example, the oxidation state of oxygen molecule is equal to 0. Similarly, for any other element which has not combined with another element, the oxidation state will be equal to 0. So the next rule is about the oxidation state of oxygen, which has to be always considered as -2, with the only exception for peroxides, in which the oxidation state of oxygen is equal to -1. Next, and the final rule is about hydrogen, in which the oxidation state of the hydrogen is always taken as +1, with the exception of metal hydrides, in which the oxidation state of hydrogen should be taken as -1. So along with all these, another very important thing that should always be considered about the elements having more than one oxidation states. So the oxidation states of all such elements should be represented by a Roman numeral when we are naming the compound. This should be written after writing the name of the compound, as shown in some of the examples ahead. In the case of potassium dichromate, after writing the name, a Roman numeral 6 is indicating the oxidation state of the chromate in the molecule potassium dichromate. Similarly, in potassium manganate, the manganese is the element having more than one oxidation states, represented by the Roman numeral 7. I hope that you have found this video very helpful in order to understand the rules for determining the oxidation states of different elements. Don't forget to watch the video code number IBC 9.1, which is about the definitions of oxidation and reduction, as well as oxidizing and reducing agents. Please don't forget to subscribe the channel, press the bell icon for the latest updates, and drop a comment or any questions in the comment section below. Thanks a ton for watching. Hope to see you again soon.